Hi there, Mr. Holcomb here with another episode of the Math Behind the Modules. In lesson 22, we'll be solving equations using algebra. So the classwork says in this lesson, you will transition from solving equations using tape diagrams to solving equations algebraically by making zero. In other words, using the additive inverse. And making 1. In other words, using multiplicative inverse. Justify your work by identifying which property you used for each step in solving the problems. It's kind of like a two-part proof. Explain your work by writing out how you solve the equation step by step, and relate each step to those used with the tape diagrams. Okay. Here we go. Example 1. Yoshiro's new puppy. Yoshiro has a new puppy. She decides to create an enclosure for her puppy in her backyard. The enclosure is in the shape of a hexagon, which is a six-sided polygon, with one pair of opposite sides running the same distance along the length of two parallel flower beds. So that's the first part of information we need. We know that this line here, actually let me change my pen. Let's use my shape recognition pen. So I have this line here, and this line over here, and they're parallel. And they're the same distance. So that's x, and that's x. We don't know it, but they say they're the same. So x equals x. Okay. There are two boundaries at one end of the flower bed that are 10 feet and 12 feet respectively. So if this comes out 10 and this comes out 12, or the other way around, then and then they said it's similar at the other ends. Okay, so there's our hexagon, six-sided figure. So this is an enclosure, and let's make this 10 and this 12. Okay, and these are all feet, right? 10 and 12 feet. And the other two end boundaries are 15 and 20. So let's call this one 15 and this one 20. Don't worry about it being what we call to scale, just so long as we have a picture. Okay? So these are all in feet. So that's the first thing we always like to do in algebra. If we have a word problem, draw a diagram and label all the gives. So we've done that. So the question says, if the perimeter is 137 feet, so I'm going to write that in here, what is the length of each side that runs along the flower bed? In other words, what are the lengths x? Okay. Well, perimeter is the sum of all the sides added up. So to add this up algebraically, let's just start here and work our way around clockwise. It's always a good idea to pick a starting point and go clockwise around so you don't miss it. This side here is x plus 12. Working around clockwise, the next number is 10. Plus, don't know the length of this side, so I can put the x, plus 20, plus 15. Be careful not to count something twice. We started with x, do not finish with it again. That's going to be a wrong answer. Okay, so now that we've done that, we want to combine all of our like terms. Well, we have x's, they're called a variable, and we have numbers without variables, which we call constants. Constants. Okay? This is constantly 12. It doesn't change. This varies. I can plug in values for x to change the value of our perimeter. If I wanted longer perimeter, then I would make x bigger. If I wanted shorter, I'd make x smaller, and so forth. So we're going to combine our like terms. So I'm going to do this color-coded. So x will be green. X and x. So I'm going to say x plus x. I just put them together. And then I'm going to put all the numbers together. Plus 12, plus 10, plus 20, plus 15. All I did here was rearranged our expression, which is the commutative term. Order does not matter. Okay, so now we're going to combine like terms. So in class I represented x. I said let's call an x an apple. So if I have one apple here and one apple over here, then I have a total of 2 apples. Well, if I have an x here and an x here, that's a total of 2 x's. So when we add x's, you just write the x one time, and the number in front is how many you have. And then I add these all up. 12 plus 10 is 22, plus 20 is 42, plus 15 is 57. Okay, now keep in mind that this is not an expression we're working with, it's an equation, and the perimeter is 137 feet, so I've got to add to this and say equals 137, equals 137, equals 137, okay? So just move this so I can work. So now this became 2x plus 57 equals 137. Okay, now up here I saw something that said making 0. We want to make 0. And that is called the additive inverse. So how do I make 57 0? That's what they're saying when they say make 0. In other words, we want to get this x all by itself. That's the whole goal. Get everything away from x. This is an equal sign. In order to make this 0, I've got to subtract 57. So 2x, and there's nothing here, so it's still going to be 2x. 57 minus 57 is 0. And if I subtract 57 from the left, I have to subtract 57 from the right, or my equation is no longer equal. Okay. Think of a balance beam, not a balance beam, seesaw or teeter-totter, or even a scale with two sides, a balancing scale like Justice said. And if I put a stone on the left side, it is now going to weigh it down, and it's going to drop lower than the other side, and so on and so forth. So what we do, when we add or subtract from one side, we have to do the other to keep it still in balance. So I'm going to subtract 57 from both sides. 7 minus 7 is 0. 13 minus 5 is 8. So now I have 2x equals 80. Showing 0 is not necessary because anything plus 0 is itself. Now this is a multiplication problem, and up here it is saying that we are going to make ones by using the multiplicative inverse. Well, multiplicative inverse means to take the inverse of the number and multiply by it. So over off to the side here, I can represent 2 as 2 over 1. If I multiply by its inverse, the inverse means to just make the denominator the numerator and the numerator the denominator. Another word for that is reciprocal. If I multiply those now, 2 times 1 is 2. 1 times 2 is 2. 2 divided by 2 is 1. So that's what they mean by make 1. So in order to make 1, this is 2, so I have to multiply by a half. Multiplying by a half is the same as dividing by 2. Divide both sides by 2. 2 divided by 2, as I said, is 1. 1x equals 80 divided by 2, which is 4. The 1 is not necessary because 1 times anything is that anything. 1 times 5 is 5. 1 times 100 is 100. 1 times x is x. So my answer now is x equals 4. So this is 40 feet. And this side here, since they were parallel and equal, is also 40. How do I know for a fact? Check. 40 plus 12, 52. Plus 10, 62. Plus 40, 102. Plus 20, 122. Plus 15, 106. Always check your work. Example 2. Jenny is on the local swim team for the summer and has swim practice for 4 days per week. Okay? 4 days per week. The schedule is the same each day. The team swims in the morning and then again for 2 hours in the evening. So they have a morning swim plus 2 hours in the evening. Okay. So those are our givens. We don't know how much she swims in the morning, but we do know she swims 2 hours in the evening. And they told us she swam 2 hours the whole week, or 12 hours, in the whole week. How long does she swim each morning? So in order to set up this as an equation, let's let x equal number of hours morning swim. Hours morning swim in hours. Okay, so I'm going to say x plus, and she swims 2 hours at night. I don't want a variable there. Hours doesn't change. She swims 2 hours every day. I was just labeling that as 2 hours. I don't want a variable there or a label. I just want x morning hours plus 2 hours in the afternoon equals 12. Well, this isn't quite right yet because this is only considering 1 day. Morning swim plus 2 hours in the afternoon. That would only be 1 day. So then if how many days are we doing it for? And it is 4. So I'm going to put out here times 4 days. So she swam in the morning some period of time plus 2 hours in the afternoon, 4 days. So there's our equation. 4 days times morning swim plus 2 hours in the afternoon equals 12 total hours. How many hours did she swim? Okay. PEMDAS. Let's just talk about this now. And now they're calling PEMDAS GEMDAS because they want to get away from parentheses and say grouping instead. We have grouping. That's the first thing we do. But I can't add x plus 2 because I know what's called like terms. So there's nothing I can do there. Next step is exponents. We don't have any exponents. Next one is like that. Squared. So there's x cubed. That'd be an exponent. So we don't have that, so we don't have to do that. Okay, multiply. And that's the next step. So we do have multiplication. We have 4 days. We're doing the same things 4 times. We're going to multiply it by 4. This is called the distributive property. And 4 times x is simply 4. 4 times a positive 2 is a positive 8 equals 12. Be careful not to multiply the 4 times 12. It is not in the parentheses that's next. So now we have 4x plus 8 equals 12. Again, we want to get 0 with our addition, so we're going to subtract 8. So we're going to end up with 4x plus 0 equals 4, or simply 4x. We want to get 1x, so we have to divide that by 4. We do to one side, we do to the other. The 4's cancel, leaving us with 1x, 4 divided by 4. So how long does she swim each morning? The answer is, and you can always check, if she swims for 1 hour in the morning plus 2 hours in the afternoon, that's a total of 3 hours per day. And if she's swimming for 4 days, 3 hours every day, does in fact total 12 hours that we were talking about. Okay? That's algebra. Okay, now it was the students' turn to try. We didn't get to this lesson in class. I'm hoping that I will encourage everyone to watch this video and ask questions if they have any. So that's kind of like flipping the classroom. Watch the lesson on your own and ask me questions. So I'll pause the video here so you can try this and come back when you're done. So pause it. Okay, so now let's solve this. I have 5x plus 4 equals 19. Solving algebraically. So again, I want to mention this. When we are working with an equation, we are doing PEMDAS. So I'm going to erase this and write it in reverse. And I'm going to change that to a G because we are doing grouping now instead of parentheses. So it's sad mag. So we're going to subtract first and add first. Subtraction and addition first. We have addition. Okay? So my whole emphasis on equations is when you have an equal sign to get from one side to the other, we do the inverse. The inverse of addition is subtraction. The inverse of subtraction is addition. the inverse of a multiplication is division, and the inverse of division is multiplication. There are more, but that's higher maths, so we're just going to stop with these four operations. So we have a plus sign. We have an equation, and we have a constant added to a variable. Remember, our goal is to get this variable right here by itself. Okay? So I have addition. The inverse of addition is subtraction. So I'm going to subtract because I want 0. I want any numbers by themselves, no constants on the side. So when I do that, I get 5x. 4 minus 4 is 0, so that's nothing. And 19 minus 4 is 15. This is multiplication. The inverse of multiplication is division. So I'm going to divide by 5. 5 divided by 5 is 1. They cancel. I get x. 15 divided by 5 is 3. Now, it says solve each equation algebraically using if-then statements to justify each step. So I will do the next one like that, but I'm just going to finish here. I'm not done yet. It doesn't say what to do here, but I would highly recommend checking. I got x equals 3. So now substitute 3 in place of x and see if it is true. 5 times 3 plus 4 equals 19. Multiplication, so we're doing PEMDAS now. 5 times 3 is 15. Plus 4 equals 19. 15 plus 4 equals 19. And 19 does 19. Okay, now I'm going to do the if-then format on this one. So it's 15x plus 14 equals 19. So I'm going to say if 15x plus 14 equals 19, then (15x plus 14 equals minus 14 equals 19 minus 14. Next step would be if 15x plus 0 equals 15, or 19 minus 14, which is 5. 15x plus 0, this is my 0, equals 19 minus 4 is 5. If 15x plus 0 equals 5, then 15x equals 5. If 15x equals 5, then 1/15 times 15x equals 1/15 times 5. So I'm just showing this as a multiplication of the reciprocal, same as dividing, okay? So then I'm going to move over and say, I guess we could put this in parentheses too, just to separate a fraction in parentheses. So then I would say if these cancel, 1x equals 1/3, then x equals 1/3. This is just all the processes with if-then statements, just to get you to the point where you understand the situation. And let me just move this down. Okay, now what are the steps we'll do? Okay, right here, this is the subtraction property. Of equality. For the additive inverse of 14. So yes, I understand that this is a lot of steps, but if you take the time now to understand what is happening, it will make it much easier. Okay? And then what's this mean? 15x plus 0 equals 5. Well, when we add 0 to anything and get that same number, that is called the additive identity. The identity is what we can add to something and not change it. It's just 0. Okay. And then we're going to go on to the next step right here, and this is the multiplicative property of equality. For the multiplicative inverse of 15. Okay, multiplicative inverse of 15 is 115. Okay, and then we get down to here, 1x equals 1/3, then x equals 1/3. That is the multiplicative identity. Okay, so the additive identity is 0. The multiplicative identity is 1. Okay. Claire's mom found a very good price on a large computer monitor. She paid $325 for a monitor that was only $65 more than half the original price. What was the original price? Okay, let x equal original price. In math, we love the variable s. That's why we do not use x's anymore. We use dots. So let x equal the original price. So it says 65 more than means plus. And if you remember going from a word problem to a mathematical expression, you see the word more than or less than, and you do what's last first. And then, so you read it backwards. So half the original price, half the original price. More than means plus, and what came before that? $65. $65 more than half is $325. So there's our equation. So you're going to have to practice word problems and converting them into equations. If you did this any other way, they may not remember. Okay, so now we have to solve for x. Our goal is to get this all by itself. I have a plus here, so I'm going to get rid of that first by subtracting. Minus 65, minus 65. I would recommend, or I would encourage you to try this a few times until you get the hang of this. But I'm going to continue by doing it this way. And when I do this, I'm going to get 0. 1/2 x doesn't change. Equals 0, 6, 260. Okay, so what I would say here is the same thing I said up above. Subtraction property of equality for the additive inverse of 65. And that's what got me to here. Okay, and then it says additive identity. So then I can simply just say 1/2 x equals 260. Zeros. So that's the additive identity. Then I'm going to multiply both sides by 2. Okay? Because I have a half of x, I want 1x. So that's called multiplicative property of equality for the multiplicative inverse of 1/2. So the multiplicative inverse of 1/2 is 2. Flip 1/2 over, you have 2 over 1, which is simply 2. I can write it as 2 over 1. And then what happens is the 2's cancel, the 1's cancel. Anything divided by itself is 1. 260 times 2 is 500. And then I'd simply say x equals 520, because that is the. So the original price of the TV or monitor was $520. So you paid $325 for one of those, $65 more than half the original price. Okay. So if I take half the original price and check, okay, now we want to check. So we're going to take our equation that we had, 1/2 our x, which is 520, plus 65. That should equal 320. 1/2 times 520 is the same as 520 divided by 2. And if we divide 5 by 2, we get 2 is remainder of 1. Divide 12 by 2, we get 6. 0. Plus 65 equals 3. 5 plus 0 is 5. 6 plus 6 is 12. Carry the 1. And it checks. Okay? This is the distributive problem. So we are going to distribute the 2 times the x into 2x. 2 times a positive 4 is positive 8 equals 8. That's the first thing we want to do. There's another way we can do this, and I'll show that in a moment, but I wanted to show the distributive problem first. Now I want to get the x by itself by subtracting 8 from 6. This is going to give me 2x plus 0. This is going to give me 10. And the additive identity says that that is 2x. And then I multiply by the reciprocal, or the inverse, multiply by 1/2. It's the same as dividing by 2, by the way. I get 1x equals 5, which is the same as saying x equals 5, because the multiplicative identity. And we're done. We get x equals 5. So to check that, I would do 5 plus 4. So all I did was plug in this x, 5, my answer. PEMDAS says to do the grouping first, and then 2 times 9 is definitely 18, and my answer checks. So the answer is, here's another way I can do the same thing. Okay, here's the original problem again. I can first get rid of this 2 outside, because it's this times this, and whenever we have multiplication and we're crossing an equal sign, we multiply by the inverse, or we do the inverse operation of multiplication, which is division. So I'm going to divide by 2 or multiply by the reciprocal, 1/2. So 1/2 times 2 is 1 times x plus 4 equals 1/2 of 18, which is 8. This 1 is not necessary because of the multiplicative identity. So now I just have x plus 4 equals 9. And then the additive inverse is subtraction. So we're going to subtract 4, so we get x plus 0 equals 5. The additive identity tells us that we just need this portion. X plus 0 is x equals 5. And regardless of which way we did it, we got this. Number 5. Ben's family left on vacation after his dad came home from work on Friday. The entire trip was 6 hours. Dad was very tired after working a long day and decided to stop and spend the night in a hotel after 4 hours of travel. The next morning, Dad drove the remainder of the trip. If the average speed of the car was 60 miles per hour, what was the remaining time left on the second part of the trip? Remember, distance equals rate multiplied by time. So there's my equation, d equals rt. Okay. What are we trying to find out? What was the remaining, so I'm going to underline that in a different color. What was the remaining time left to drive the second part of the trip? And that's going to be our variable. So what was the remaining time left driving? Okay, so let's just try solving for t. We're talking about time, right? Miles per hour. What was remaining time left to drive on the trip? So let t equal time remaining on the second part of the trip. Time remaining on the second day. Time remaining on the second day. So I'm going to come up with an equation. He drove 4 hours. We don't know how much he drove in the morning. So the time plus the 4 hours from the day before. He drove an average of 60 miles per hour. Per means to multiply, by the way. Per means times per hour. 60 times t plus 4, and the total distance of the trip is 600 miles. So there's our equation. The hardest part of this is getting an equation out of paper. So here's our equation. So now I'm going to get rid of this 60 over here. I don't care if you divide by 60 or multiply by 1 over 60, but I'll show it as multiplying by the reciprocal. Okay. Multiply by 1 over 60. It's the same as dividing by 60. So these are going to cancel. Okay, t plus 4 equals, and 600 divided by 60 is the same as 60 divided by 6, which is 10. So now the multiplicative identity says that 1 times t plus 4 is t plus 4 equals 10. Subtract those 4 hours from both sides, and we get t plus 0 equals 6. The additive identity says that t plus 0 is simply t, and we get t 6 hours. Okay, still has 6 hours to drive the second. That's the end of lesson 22. It's a very important lesson. Please watch this more than once. Do the problem set. Ask me questions.